we'll get all of that done. Okay, ready? Product rule, x is a function. If it's x times g of x, it's still a function. The only thing I don't have to worry about are the constants, and maybe we should show why that is. So how do I find h prime of x? I wish it were as easy as f prime times g prime, but unfortunately it's not. And if you try some things, you'll see that it doesn't work, because it doesn't work when you multiply a couple functions out. You get a different answer. So it's f of x times g prime of x plus g of x times f prime of x. Now that's not a proof. If you want a proof, you probably can read the book. Or if you want me to prove it, I'll prepare it. I can't just do it off the top of my head. I know you think I can do that. No, I can't. So what if we have a constant? What if h of x is equal to some constant times f of x? Is that okay? Okay. How do we find that derivative? Well, we can use the product rule. And somebody may say, I don't really need to because that's a constant. Okay, so Grant, we go k times f prime of x. y1. Not doing chain rule. No chain rule. Plus, then it's f of x times the derivative of the constant. We're doing the product rule. This is what we didn't do. I didn't get to it. Okay, so that's times 0. So if you have a constant here, this should be a prime. So h prime of x is equal to the constant times f prime of x. It's the same as taking this constant out of the derivative operator. Why does it work? So h prime of x is equal to k times the derivative with respect to x of f of x. Well, I just showed you why it works, because if you use the product rule on the constant times the function, you get the constant times the derivative plus the function times the derivative of my constant. But what is the derivative of a constant? It's 0. So this is the easy way to do it. And we always come back, why can you do that? Just go back and use the product rule. Product rule always applies. It's just that this term always ends up being 0, so that's why we can pull the constant through the operator, which is nice. Okay, do you remember the product rule now? Okay. And the quotient rule. Now, do you remember how we did this one? We did h of x is equal to high over low. Remember the pretty high? So h prime of x is equal to what? Low d high minus high d low over the square of low we go. Never, ever expand that. It's not worth the trouble. And if you can reduce your fraction, it has to be multiplication anyway. Do not expand. It's a waste of time. Remember, this is a timed exam. So you don't want to be doing things you don't need to do. So don't do that. Now, what do? I just do the problem. So h prime of x, let me just change colors. H prime of x, it doesn't matter if you want to use this or use my method or whatever method works for you. It's the denominator. I start downstairs and I go upstairs, then I come back downstairs. So it's g of x times the derivative of f of x minus, then it's f of x times the derivative of g of x. So it kind of looks like the product rule, except that's minus, order matters, over the denominator squared. And I don't even think I put an example on here. Did I? Do you need one? I don't think so. So we're flying through the AV material, refreshing your memory. So we are going fast. By the way, they go this fast at college. But that you're not taking 6 subjects in college and doing a sport and doing whatever else you're doing. You will be focused on your 3 or 4 classes. And if you are in a Division I school, you'll be spending a lot of time in your sport. Okay. Is that one okay? Now let's go back to this one. And hopefully you got these. Do you remember the derivative of the sine?
Cosine.
Cosine. Now, do you remember my little hints? I know it's exciting to see the first snowfall, except it's not sticking. Okay, you guys, remember my hints? The derivative, the derivative of the cofunctions will always be negative. All the cofunctions are negative. So this is derivative of cosine is negative sine of x. Well, you will now. I did say it, but sometimes you guys don't listen to everything. I remember tangent. It's secant squared. And we can prove it if you want me to. It's the quotient rule. And then I do secant next because that's the one I remember. Kind of like the co-ones because they're negative. So secant is secant back again. You remember what the next part is? What's the next part? Times the tangent of x. So I memorized that one. Then what's cosecant? Using the pattern here. It's negative. Well, it's secant. Cosecant. These match. And if this is tangent, probably not tangent, it's cotangent. What's the derivative of cotangent? Well, I remember the tangent is secant squared. Cotangent is negative. It's not secant squared. What's the other one? Cosecant. That's how I memorize them. And why do I care about memorizing them? Because you can always work them out. Because when we do antiderivatives, you need to recognize that when you have secant tangent, that its antiderivative is the secant. Not an easy thing to do unless you have them memorized. Okay, so shall we do this problem? And we aren't going to worry about simplifying because I don't care about simplifying. And that was the most frustrating thing on the exam was grading things that kids simplified and they did it wrong and they earned their points and I had to take them back. I don't like doing that. Oh yes, if you write wrong mathematics, you get taken off. If you write too much and it's right, you're okay. If you write too much and it's wrong, we take points back. Well, it's not always. It depends on your chief, not your chief, your question leaders, how they want to grade it. So every question has a different person who is the leader for that question, and they decide on what the scoring is going to be. They select a bunch of student papers. They get there a week before the readers get there. They select a bunch of random papers, and they grade them, and they try to get a consistent scoring rubric. So they make the decision of how something will be scored. And then after that, it's engraved in stone, and I can't go off of that at all. I have to do exactly what they tell me. Okay? Okay, so let's find the derivative of this. The y dx. Okay, can we ignore the 2? Yeah. Yep. Do you remember? You got the cotangent right in front of you. What is it? It's negative. Lizzie, do you remember what the cotangent is? Derivative of cotangent. Cosecant squared. And even I have to think about it because I don't see the cotangent that often. So I haven't really memorized it that well. And then it's minus, I'm going to use parentheses because it's minus this derivative. Grant, do I need to use the product rule here?
No.
Yes. Yes, because of the time sign at the product. I don't know. I think sometimes you don't realize these are two different functions, or maybe they don't put the dot there. I don't know what the problem is. But this is x to the 1/2 times the secant of x. Okay, so it's x to the 1/2 times the derivative of the secant. What's that one? Secant is secant tangent. Kind of has a little rhythm to it. That's how I remember it. So that's secant of x times the tangent of x. Yeah, it's got a little rhythm to it. Secant is secant tangent. I don't know. Well, for me it does. Whatever works. Plus, then you leave the secant of x times the derivative of x to the 1/2, which is 1/2 x to the what? Negative 1/2. Do I have to do anything to simplify that? No. It's good. It's done. Check your answers online. The only reason why you would have to simplify, and this would not happen on a multiple choice, was that you have to match your answers on multiple choice. That'd be the only reason. And they do get you on the algebra and the multiple choice section. If you want me to kind of simplify it, there's not much I can really do with it, honestly. Because now you start getting into trig identities. Well, that's 1 over sine squared, and do I want to do that? Well, this is minus the square root of x, secant of x, times the tangent of x. Oops, forgot my x. Minus 1 over 2 square root of x, secant of x. And honestly, there's nothing I can really do to simplify that. I suppose there's some identity. I could condense it. The only reason we needed the identities is because we did everything on slide rules and used tables, table of values. That's it. So well, now with calculators, do I need it? No. Okay. So that's it. My guess is it's 3, 4. I don't even know what it is. Do you have questions on any homework questions, or do you just need time to work? Well, we'll give you the test back too, but the first question is, are there homework questions or work time? Now, you need to check your answers. I know some people are doing that. I don't give you the easy questions. Sure, on the homework? Sure. Yeah, I think that'd be great. Well, by the way, here are the slides. There are some answers there. Well, I don't know. It's on an assignment sheet. Does anybody need it still? If you haven't tried it, you don't know what to ask. Does everybody have an assignment sheet? Yeah, which one? On which section? 3-1, 58. We never did come back and do the monk problem, where he's going up and down the road. Okay, you should have your book out. That's my book. No. Yeah, I'm nervous. 58 sounds like it's hard, right? Yeah. Oh, I like this problem. Okay, you guys, we're going to do these problems together. Don't. Can you put those away, please? Okay, there's 3, 3. Some problems. I'll just save these. They're from last year. But we're going to do 3.1, number 58. Maybe you guys want to come up and do it. Now, this problem was a problem that was assigned at the University of Minnesota. And they collect the homework and they grade the homework. I can't ask you these hard questions on a test. The testing time isn't long enough. At the University of Minnesota, I think it's like a 2 or 3 hour test. Everybody takes it at once. Yeah, it's a special schedule to do that. So, and then we would all get together, the teachers would all get together, and we'd divide up the tests, and I would grade a single problem, just like I do for the advanced placement. And other people would grade the other problems. So you never knew who was going to grade your part of your test. It says, find equations of both lines through the point 2, -3. Am I on the right one, right? Yeah. Okay. So it's going to go through 2, -3. And it's tangent to this parabola. Well, let's just do A. Then we'll see what B is. Okay, Grant, you got paper, pencil? Ready? You can do it on the back. We should have done that one, too. Okay. What should I do with this? I'm cheating. No, before I even start that, I should probably draw a picture. You're right. What's going to be on the exam? If it's tangent, you know it's going to be derivative, right? So you know you're going to have to do that. But yes, we are done testing the definition. Still should look at that extra credit problem. Okay. I didn't look at that problem. You should, though. It was an actual problem. So I want to graph this. Now, I know what that looks like, but do you guys know what it looks like? It's x squared plus x. It's a parabola, isn't it? Okay. What would be nice to know? Where the graph crosses the x-axis. Okay. So I'd like to look at the x-intercepts. And remember, how do we do that? Or how do we do that? We factor it. Now, when you solve an equation, you're looking for numbers that make the sentence true. There's nothing wrong with guess and check. Okay, at the university they won't accept guess and check. But in reality, if you really want to know your mathematics, there's nothing wrong with it. You will take the next one at the university. You're going to become a doctor. You have one more year calculus. Okay, Grant, where are these intercepts? Okay, so we have 0 and -1, and I have a parabola. And I know it's going to open up, right? Hopefully I'm in reasonable shape. By the way, where is the vertex? Now, in higher algebra, only reason why I know it is because I subbed. It's halfway between these intercepts. It's -1/2. That's right.
Wait, how far below does it go?
Well, we could find that f of -1/2 is equal to 1/4, because I'm just going to square that, minus 1/2. So that's 1/4 minus 2/4. So it's -1/4. Well, I would kind of like to know that, because I have to graph this point, and I want it relatively in the right place. So this is 2, -3. Won't be exactly relative.
Yeah, see, look how far the -1 went.
I know. So it's going to be way down here. 2, -3. It's pretty close. Okay. Now, I want to find the equation of the tangent lines. Is there more than one? That one looks good. And my guess is there's probably another one that's probably way up here. Well, I got to figure out where this is. So this requires a little bit of algebra. But I can find the slope two ways. I can find the slope with the derivative, which of course you think is the easy way, right? What's the slope with the derivative? Because I want to find the equation. Oh, because I want to know what it looks like. I just wanted a picture. I can't do this. I can't do it without a picture. Okay, Drew? True. But you have to have the general idea of where we're looking for this line here and this other line over here, wherever that is. What's 2? I don't know what the slope is. I know the slope is 2x plus what? 1. Okay? Now, there's another way I can find the slope. The old-fashioned way. I have to figure out where that is. What is that ordered pair? It's x comma what? Okay, we can do y. I know what y is, though. What's the slope between these 2 points? Yeah, we're going to subtract them. Okay, Trevor? It's y minus a -3 over x minus 2. Where do you think point slope formula comes from? It comes from this. I could. Just showing it, because that looks like magic sometimes when I change the signs. And I want you to see that's what it is, and then I'll change them. Sam? This is from the derivative. This is equal to f prime of x. And guess what? This is equal to what? That slope, 2x plus 1, isn't it? No matter how I calculate the slope, that's right. I haven't figured out what x is. That could be negative, right? So this is 2x plus 1. And you're saying, but wait a minute, I have a y in there, and I don't like a y. What is y? What is y? X squared plus x. So it's x squared plus x, because it told me that. That's the tricky part. Realizing that y value is x squared plus x. Because that's the y coordinate on my little graph here. Okay? So x squared plus x, I'm going to put in for y. And then somebody said, why did you leave it minus and -3? I'm not going to leave it that way. It's plus 3, right? Over x minus 2 equals 2x plus 1 over 1. Can I solve that and find x? Let's do that. Because that's called a proportion. Right? We cross multiply. So x squared plus x plus 3 equals, and I'm going to set it up because I want to get it right. 2x plus 1 times x minus 2. And I try to do that in my head. I know I'm going to get it wrong. So let's see. Probably should do it. 2x squared. Can we go ahead and do this in our heads? You know, sometimes I might write it out over here.
Minus 3x.
I might do a little bit of thinking over here, scratch paper, whatever. But it's minus 3x. That's right, Grant. And then it's what?
Plus
Minus 2. Now, to solve any equation, we want it equal to 0.
I bet you could add 3.
Is this the squeeze through?
No.
I bet you could add 3 to one side. Add 2.
I want this to be 0 on this side. Now, can we do this without me showing work? I'm going to get rid of the x squared here by subtracting it and subtracting it there. So that's going to give me x squared. Now, if that's too fast, you have to let me know. Now I'm going to subtract the x side and subtract it from this side. So it's minus 4x. When you get into those upper level classes, they're expecting you to be able to do what I'm doing without writing it out. And minus 3 here and minus 2 is there, minus 5. And how many answers should there be? 2, because of that exponent. That's the fundamental theorem of algebra. It says if the exponent is whatever it is, and there are n solutions. There's at most n real solutions. In this case, they're both real because we can factor this. Can we? Minus 5 plus 4. So x is equal to 5.
Oh, yeah.
Sorry.
Whoa.
I'm just reading the 4 off my thing there, plus 1. And x equals negative 1. Well, that looks reasonable over here. Does negative 1 look reasonable? My graph's not great, but it looks reasonable. And 5, how tall is that? What is f of 5? It's 5 squared plus 5, so it's 30. That's right. So, you know, if this is counting by 1, there's no way I could even draw it the way I have it drawn. Okay, I haven't finished the question, though, have I? Okay, so we have 5, and we had 30. What happens if we have negative 1? What's the y value? It's x squared plus x. It's 0, isn't it? And then you write the equations of the lines. Now, which way do you want to find the slope? Do you want to use calculus and use this side? Or do you want to do algebra and do the other side? I want to use the calculus because it's easier. I mean, you better get the same slope either way. So what's the slope for this one? If x is 5, the slope is 2 times 5 plus 1. And the slope here is negative 1 times 2. Make sure I did that right. Plus 1. And so that is equal to negative 1, right?
Yeah.
And m equals 11. Why is this problem hard? Because it has a lot of steps. It's not hard when you break it down. I first graphed it. I said, let me draw the picture. What do I know? I need to know where this ordered pair is. Because I can't write the equation of a line. And I probably should have written y minus y1 is equal to mx minus x1. Because that would tell me that I need to find the x coordinates and the y's and the slope. So then I think, well, how can I find it? Can I get an equation I could solve and find out what x is? So we're going to write them both. Because we still haven't answered the question. Okay, so it's y minus 30. What was the slope for this point? That was what, 11? It's 11. And then it's x minus 5. That's the one line. And the other one is y minus 0 equals slope, which is negative 1. And then it's x minus a minus 1. You would get full credit for minus 1.
So if we said x plus 1,
You're fine as long as you do it right. So y equals, this is minus x plus, sorry, you do that right. It's minus 1 times x plus 1, or y is equal to minus x minus 1, which hopefully makes sense when I look at my picture. It's supposed to be this point right there. Now, these are nice numbers. Could you maybe guess? Probably. But in the real world, you're never going to get nice numbers. Where would this be used? Maybe in satellites, predicting paths. You want the rocket to meet up with the space station, the Russians at least, because we don't have that anymore. But you might want them to meet up, and this is the same type of thing that you would do. This would be a model to use to calculate where everybody's going to be. Unfortunately, it's in 3 dimensions, so the math is quite a bit harder. Did you ever see Apollo 13? And what happened to the computers? They didn't work, did they? And they had to do all their calculations by hand. You never know when that might happen. Now, do you guys understand, while I'm here, why? Why what? Well, you might be also talking about delivery meetup. If you take further math or discrete math, you'll find out you have to get the paths that are the most efficient. It's like graph theory. When they plow the roads here, they don't just go out and randomly plow the roads. They have a plan so that they would get the drivers go down the least or fewest number of roads. Somebody had to do it. And so guess what? These things are done for you. What does that mean you get to do? You get to go to the next step, something more advanced yet. That's how we got to where we are with everybody having technology. My grandparents were born horse and buggy. No bathrooms. That's my grandparents. They had probably the most fascinating lives, if you think about it, because they grew up with horse and buggy. And when my grandmother died, she had a Cadillac sitting in her beautiful home. Yeah. So they went from that type of thing through all those cars to a very nice car. And now, think of where we started. We had dial-up phones. You had dialed, rotary dial, and now we all have cell phones. So many of us don't even have house phones anymore. But do you guys know where that formula comes from? I mean, I teach it when I teach it, but I didn't have all you guys. You know what I found in algebra? Yes, we will. That if I did this and I asked them for a table of values, they could tell me that the slope, that this change is x minus x1. And they could tell me that this change is y minus y1. And how do you find the slope with rise and run? It's rise over run, right? So that would be y minus y1 over x minus x1. Okay, Lizzie, you might be interested in knowing where the formula comes from, because once you know that, you will never forget. And that's the slope, and they use m, and that's from French, from monter, which means to climb. And what do we do with this? Exactly what I just did in this problem. We cross multiply. Y minus y1 equals m x minus x1. So what I did with my algebra kids, because they could do this by putting numbers in here, I left this xy and I put in a 2, 3 there, and they could go right to point slope form without a problem. Well, it was a little bit of a problem, but not bad. Way easier than y equals mx plus b. And it makes sense, because this is just the slope between these ordered pairs. That's it. So I'm just showing you in a different way. And it wasn't until this year that I had thought about the table idea. So I'm always learning new things, new ways to look at things. But I thought that was kind of cool. Okay. Most of you want to get your tests back. So people who haven't taken the test either have to leave or go out in the hall, but take your work with you